All right, hey everybody, welcome to our latest edition of Cloudy with the Chance of Learning. Meteorologist Meagan Massey's one of your favorite topics today.
And it's all about space, our planet. So, last week we had part one. We talked about the sun. That was the first thing we started out with. And if you happened to miss last week, just remember that our part one of the solar system still lives on our Facebook and YouTube page. And we're still live, daily at 1 p.m. So you can go back and watch part one if you happen to miss that. And then part two will also live on our Facebook and YouTube pages. And if you have any questions or even comments, make sure to comment below and we'll do our best to answer your questions as well.
Yeah, and this is a really fun topic because we get to talk about things beyond our atmosphere.
Going above and beyond.
Yeah, above and beyond. And this is the perfect day to do it. I mean, Meagan, you really thought this through. It's Star Wars Day. May the 4th be with you.
May the 4th be with you. Yeah, and the star background and everything. So it just comes hand in hand.
Yep, so we're going further into the solar system as we head throughout today's lesson of Cloudy with the Chance of Learning.
So we have Emily from 1st grade. Hey, Emily, glad that you're here. Ainsley, also from 4th grade, says hi. Happy to have you back. I know you're one of our loyal Facebook Live watchers, so thank you so much for joining us. Matthew, also joining us today.
Emily's here. Meteor showers tonight. Rick, the answer is yes, there is going to be a little bit of a contribution from Halley's Comet, that is expected to be going on for tonight. Something cool to look up at into the night sky.
But it could be a little tricky because of clouds, right?
Right. Yeah. Now, typically you'd see those a little bit more after midnight, but you want to try to get out and see them as early as possible.
Yeah.
Because the cloud cover will build in as we head later into the night. So, I guess you could say closer to the peak of viewing meteor showers, it won't be as good, but if you could get out earlier this evening, the better.
Okay, so we talked about the 4 planets. Can anyone name the order of the 4 planets after the sun? Sun's actually included because we did touch on that just a little bit. And remember, Mercury, my favorite, I kind of gave a hint there, but didn't give you the exact order. Mercury is one of my favorite planets now because of the features and craters named after famous artists and musicians and also authors. We talked about the Dr. Seuss feature, which I think is just so interesting. I didn't even know that existed.
Yeah, really cool stuff about that. We talked about Venus and the greenhouse gases, the kind of overpowered atmosphere, I guess you could say, of Venus. And then we talked about right here, our planet, Earth. And we talked about the sun too, which is a star, remember, not a planet, but a star. And today we're going to go deeper into the solar system.
And we also have JJ joining us, a 1st grader at Green Valley in Cibolo. Glad that you're here, JJ.
Yeah.
So let's get right into it. You talked about the sun and how it's a star. So we talked about Mercury, Venus, our planet Earth, and the next ones after Earth would be Mars, Jupiter, Saturn, the funny planet Uranus, Neptune, and Pluto. So today we're actually going to cover 3 planets after our planet Earth because there's just so many interesting facts and information to share.
Yeah, and a lot of studies going into one of these. The first one that we're going to talk about, Mars.
Yeah. So remember, did you by chance remember the saying of the planets order that you learned back in school?
I forgot it.
I learned my very excellent mother just served us 9 pizzas. We had nachos too, just served us nachos, and some people didn't include Pluto, but we've always included Pluto when I was in school. So that's just one thing I learned. Ainsley says, my very excellent mother, Angela, just served us 9 pizzas. There you go.
Nice.
Matthew naming the order. Way to go, Matthew. Yep, exactly. So let's dive right into it. So you were talking about Mars, and Mars loves visitors, right?
It does. We have multiple systems that are controlled here on Earth, and robotic systems that are investigating Mars. And, they're always sending new things onto the planet. I think it was, I want to say NASA had a program recently where you could type your name into the system and it sent your name to Mars.
You said something funny, and I didn't know this either. They sing happy birthday in space.
Oh, yeah. So the robots on Mars sing happy birthday to themselves every year.
I think that's adorable. I don't know about you. I just think that's so cute. All right, so Mars, it's a dusty, cold desert world, and it actually has a thin atmosphere. And the thin atmosphere contributes to the temperature swings on the planet Mars. There are 2 moons on Mars, so they have confirmed names. And we were just talking about Mars missions, and the first successful Mars mission was the Mariner 4 flyby back in 1965. So we've been exploring planets and really the solar system for decades and years. So this goes well back in a time.
Yeah, and remember, this isn't explored by humans. Well, it's explored by us, but from a distance.
Like, we make the instruments. We put all the science, the physics, the technology, you know, into that. So that's what scientists do. Yeah,
but man has never walked on Mars. There's a lot of work to try to get us up to Mars to go explore it, but nothing has happened yet. But possibly in y'all's life, especially the younger ones on the Facebook Live right now, the first graders and the third graders, you may get to see that one day. We may even get to see that one day, but it's still a lot of work to be done with that.
And there's going to be a lot of future missions, not only with the US, but also other countries around the entire world studying our red planet. So why does Mars appear red? It actually has to do with rusting of iron in the rocks, Martian soil, and dust on Mars' surface.
Oh, wow.
And so that's why it has this, you know, rusty looking color, and that's why it's called the red planet in our solar system.
Oh, very cool. And it has the largest volcano in our solar system.
Olympus Mons.
Yeah, a huge volcano. That's actually part of the planet that's been studied a lot. Was people want to know more about this volcano that's out there on Mars.
Yeah, so Mars happens to be my second favorite planet, just because it also has so many interesting details about it, just like having the largest volcano in the entire solar system. So just very, very interesting there.
Oh yeah, and the robots that explore this planet that are controlled by NASA, you can find all sorts of different images they've taken online and find out all sorts of different things that they found with those, and you know, find out more about them. They're pretty cool.
And, you know, we talked about the thin atmosphere over Mars, and that's something that, you know, the robots on Mars and orbiting around Mars, that's what they study. So the thin atmosphere actually contributes to huge temperature swings. So with that thin atmosphere, heat can actually escape a lot easier on the planet. So in one day, they could reach a high temperature of 70 degrees and then an overnight low of negative 225 degrees. So 225 degrees below zero. That's crazy.
That is, that's a little too cold for me. I'll take the 70 degrees.
Yeah.
But 285 is a little, 225, excuse me, is a little cold. 285 would be really cold.
So when you think about human life, I mean, 225 degrees below zero.
You have to stay inside. Yeah. You have to stay inside. So
I don't even know if the inside could help you that much.
Yeah, no, that's pretty cold.
Yeah, so let's talk about 1 year. So with Mars, 1 year on Mars is equal to 607 Earth days. You know, it is the 4th planet from the sun, so it's going to take some time for it to orbit around. So it takes longer days to orbit compared to our planet Earth.
Yeah, remember, 1 year would be one full orbit around the sun. That's what we're talking about, all the way around the sun. It takes 687 days, which is, remember, 385 days, right? 365. I just said
365.
I've got the number 85 stuck in my head for some reason. It is 365 days for our planet to get around the sun.
You just did the forecast, so that's probably why you're thinking 85. Addison, who is 6.5, says hello. Hey, Addison, glad that you're here and hope you're enjoying the solar system talk. So we were just talking about the thin atmosphere and how it contributes to huge temperature swings. You know, in one day, it can go from 70 degrees all the way down to 225 degrees below. So just massive temperature swings because the thin atmosphere, that very thin atmosphere around Mars, heat can escape quicker. It can also very fast too.
It can. So that's one of the things that helps protect us. That atmosphere that we have over us kind of acts as a blanket, traps in the heat.
And we have multiple levels of our atmosphere too. So we've been talking about the robotic spacecrafts and also the spacecrafts that have orbit around Mars. Now, there are 2 robotic spacecrafts on Mars. You have the Curiosity rover and the InSight lander. Now, museums can open up officially. I highly recommend the Johnson Space Center in Houston, Texas, just right down the road on I-10, because they actually talk a lot about Mars. They have a Mars exhibit, very hands-on, talk about the Curiosity rover, and get this, you can actually go the kind of the demonstration of the Curiosity rover on Mars and actually drive it onto Mars.
Wow, that's pretty cool.
It's so cool. Once this is all done with the coronavirus, I highly recommend checking out the Johnson Space Center. Just fascinating stuff, hands-on learning. Astronauts will also talk about Mars. It's just a great overall exhibit. Can't hype it enough, and I just want to go back to. I've been there once, so it was last year, beginning of last year.
Nice. And yeah, centers all around the U.S., by the way, too. They have also they have Johnson in Houston. They have Kennedy Space Center in Cape Canaveral, Florida, and Stennis Space Center in a place called Kill, Mississippi, which is just on the very western part of I-10 in Mississippi.
Well, there you go.
Yeah.
And so let's talk about the 6 spacecrafts in orbit around Mars. So there's 3 with NASA. That's the Mars Odyssey, also into Meagan. And then you have India's first red planet observer, which is the Mars Orbiter mission. So that's India's mission there.
Nice. So everyone's been just kind of checking this out from the U.S.
Like I said, it's more
from the Earth.
Yeah, so it's not only the U.S., but it's also several countries around our Earth that are observing the red planet in our solar system.
Very cool stuff.
So let's move on here.
That was all about Mars. And, you know, we got more planets out behind Mars. Remember, the solar system goes and goes and goes.
Yep.
And we end up having even more out there. And we're running through the graphics again. Give us 1 second, guys.
So we talked about the temperature swings because of the thin atmosphere. That's one thing to note. And also how there are 2 robotic spacecrafts on Mars and how there are 6 in orbit around Mars. So that's another thing to note. Let's move on to the largest planet in our solar system.
This is my favorite. I love Jupiter, and it's because of the storm systems that are on Jupiter. I mean, some of the largest, most powerful storm systems in our solar system are on Jupiter.
And we'll talk about the peak wind speeds within that, the red spot, the great red spot.
Yeah, which is that big storm that I was talking about. And there it is, coming around.
So believe it or not, there's actually more than one red spots because of the jet streams over Jupiter. We talked about the jet streams on our planet Earth, which is, you know, high winds, very fast winds, high into our atmosphere. That is going to be the same thing with Jupiter. One interesting thing to note is one day on planet Earth is 24 hours, right? Well, one day on Jupiter is 10 hours.
And Jupiter is way bigger, so it takes a long, I mean, it's spinning very quick. And also something important, Jupiter is our first gas giant when it comes to our list of planets coming out from the sun. This is our first of the gas giants.
And so when you talk about the size, think about Earth being a grape and Jupiter being a basketball. So that's going to be the biggest reference there.
Huge.
Yeah, so it's about 11 times the size of Earth. So you get 11 Earths that could fit across Jupiter's equator. Just a massive gas giant.
Wow. And
it takes about 12 Earth years to complete one orbit around the sun. So remember, we're now on the 5th planet away from the sun. So it has a longer orbit around the sun, around our solar system. And that's why it takes about 12 Earth years to complete one orbit.
Yeah, and Jupiter is actually a little bit further out after Mars because there's something between Mars and Jupiter, and that's the asteroid belt.
Right.
And we're going to talk more about that on another week.
That's going to be part 4.
Yeah.
Yeah.
So, but this is, for now, we're just sticking to the planets.
So if humans were on Jupiter, we would talk funny because the gas giant consists of hydrogen and helium. So think about sucking in a balloon with helium. You're going to talk funny, right?
Yeah, so we don't have high-pitched voices.
And it has no surface, believe it or not. But, you know, a spacecraft can't just simply fly through Jupiter because the pressures are so extreme and the temperatures are so extreme. If, you know, a machine were to fly into Jupiter, it would just basically be crushed and melted.
Yeah, and you think about how all this gas is being able to stay up against the planet and possibly rocks within there too. Right. It's because of the gravitational pull. So, I mean, if something tried to fly through it, it would get just like everything else.
Right, and that goes back to Matthew's question about how gas giants stay together, and you just answered that.
Yeah.
It's got to do with all of that. And so what about, you know, kind of the appearance of Jupiter, what it looks like? It has these brown and red and even tannish-like streaks and swirls, and they are cold, windy clouds made of ammonia and water.
Oh, wow.
So kind of a difference there between our clouds on planet Earth, right?
Yeah, not as friendly clouds.
Right. Go ahead.
You got it.
Well, we talked about the fast winds very high into Jupiter. So now let's kind of dive into the big red spot. There are actually multiple, but there is the largest one on Jupiter. And I mean, it is so much bigger than a hurricane on Earth.
I know. Just think about this as being this massive storm that would take up basically, I mean, not the entire planet, but pretty much. I mean, this just massive storm that not our planet rather. So we're talking about Jupiter though. But this massive storm that is just always there. It's always there on Jupiter. Every time you look at it, that's what you're going to see as long as you're looking at the right part of Jupiter.
Right, and because it's a gas giant, scientists are actually still studying the big red spot. So there's still some question marks about the entire study and how the winds work on the planet Jupiter.
Oh, yeah.
So let's continue to talk about the big red spot. So it's spinning every 10 hours. Jupiter as a whole, we talked about how 1 day equals 10 hours. That's going to be less than half of one full day on Earth. Remember, when you compare it to Earth, we have 1 day in 24 hours. Jupiter much faster, every 10 hours. So the very fast rotation actually creates a very fast jet stream on the planet, and wind speeds can reach up to 335 miles per hour.
Ooh, that is really quick.
That is really quick. In fact, that is quicker than our wind speeds here in our jet stream on Earth. So the swirling clouds are twice as wide as Earth. So think about that too. And within the big red spot, winds inside that storm can peak at about 400 miles per hour. So even quicker, just really fast wind. Yeah,
and you know, we talked about that earlier. This is one of the most powerful storms in the solar system. I mean, that is a very strong storm.
And so we talked about the big red spot and the appearance, how it's kind of the shape of an oval, right? So that one oval is twice as wide as Earth.
Ooh, wow.
Yeah, so that's that little fun fact there. So I just want to see, so Ainsley, she's always been really curious about the big red spot on Jupiter. So you know, scientists are still studying this. What we do know is that there are very fast winds. Of course, there's no real surface on Jupiter. It is the first gas giant that you were talking about.
Yeah, and we've got more beyond Jupiter too. It has 53 named moons. So remember we talked about how it has that strong gravitational pull. Right. It keeps some moons, some things that rotate around it, almost like a satellite, which it is.
They're natural satellite. Yep.
53 named moons that are always kind of flying around Jupiter, or rather orbiting around Jupiter.
Right. So, and there are actually 26 more moons awaiting, so they don't have official names. So when you think about it, there are over 75 moons around the planet Jupiter.
Yeah. Could you imagine that for Earth? Always looking up and seeing all these moons there?
Yeah.
Well, that's what it's like for Jupiter.
And you know, Saturn is very well known for its rings, right, in our solar system. But did you know Jupiter, the gas giant, actually has several faint rings made of dust, but they're so faint you can barely see them in our solar system.
Wow.
So Jupiter, in fact, have rings around its planet.
Very interesting.
So Matthew, the answer to your question would actually be the red spot. That's what it's officially called, but I'm sure there are several names that people refer to it. I've heard the big red storm. I've heard all sorts of names, swirling wind on Jupiter, so many different things.
And Matthew, I'm not sure if it was when a meteor crashed into it or not.
Yeah.
I'm sure it would be something large though, like an asteroid, to have caused that. If it was from that though, so we're not entirely certain on that. Again, we're looking at something that's even beyond meteorology, that we actually have to do a lot of studying on ourselves. But I'm not sure. That we may have to go back, investigate that, and we'll be back with that answer for you, Matthew.
Yeah, definitely. Remember, we have part 3 and part 4 still awaiting us, so we can always research your questions and talk about it more in the upcoming weeks. And of course, we're always talking about the solar system on Mondays, at least for the next few weeks. So let's jump right into Saturn. It is the second largest planet in our solar system. We talked about Jupiter having faint rings, but a lot of people are really interested in the planet Saturn because of its rings. It's one of the most favorite planets.
Yeah, it's a beautiful looking planet. Whenever we take looks at it on from photos from NASA, or sometimes you may even see it in some of the cartoons that you watch. It is a beautiful looking planet.
So rings are made of rock and chunks of ice. I think there's a little typo there, but it's okay. Saturn actually has 7 rings, and Saturn is mostly made of hydrogen and helium. So if people were to live on the planet Saturn, they talk funny too, right?
Yeah, a lot like Jupiter. We don't talk like this.
So Saturn is 9 times wider than Earth. We talked about how Jupiter was 11 times bigger. Saturn happens to be 9 times wider than Earth.
Yeah, and that's why we call these planets, it is a gas giant, Saturn, just like Jupiter. That's why we call them the gas giants, because they're so big.
Yeah, exactly. And one day, remember, one day on Earth is 24 hours, but on Saturn, it's only 10.7 hours. So pretty similar to Jupiter in that regard.
Yeah, and was it 10 hours for Jupiter, you said?
It was 10 hours, yeah.
Yeah, so it spins a little slower than Jupiter, but not by much.
Yeah, and the average density is less than water. And so NASA was being funny about this, but if Saturn could sit in a bathtub, it would float.
Oh, wow.
If anything like that were to exist, yeah. If Saturn were to sit in the water, it would float.
A big old bathtub. And by the way, I just said that it spins a little slower than Jupiter. Because of its size, it may actually be a little bit quicker.
Yeah, it's still quicker.
I'll have to look that up myself.
It still spins pretty fast.
Since it is smaller and Jupiter is bigger, I think that I actually said that incorrectly, so I apologize, everyone.
And just like Jupiter, it has no surface too. So it's a gas giant in a way. It's not known as the gas giant, but it's a big planet mostly made of gases too.
Yeah, so another fascinating planet, though, on our stop through the solar system. It has clouds, jet streams, and storms, similar to Jupiter, and just like us. So, but these storms are likely pretty massive compared to the ones that we're used to.
And we talked about Saturn as a whole, rotating, right? And one day equals 10.7 hours. But actually, each ring of Saturn rotates at different speeds.
Oh, wow.
Yeah. So very interesting stuff there.
And Matthew says, how do the rings form? I believe it has to do with the gravitational pull there, Matthew. The gravitational pull kind of keeping them closer to the planet and kind of closer right over there, over the center.
Right. And Saturn does have many moons too. It has 53 confirmed moons and 29 moons still awaiting their official names too.
Wow. So a lot of moons. So the gas giants have really strong gravitational pulls, and they keep these smaller smaller satellites orbiting them, which are their natural satellites, so they're moons.
Right. And the rings are mainly rock and chunks of ice, but also coated in dust in the solar system, and each one orbits at different speeds. So some rings will be quicker, some rings will orbit very slow.
Yeah, I mean, fascinating stuff and beautiful to look at. If you look up images, get permission from your parents, but if you look up images from NASA, of Saturn. They are just beautiful images of the planet.
Yeah, definitely. And it's just fascinating getting to learn about each planet. Like I said, we're only covering 3 planets today. And that's because there's so much information with each of them. So next week we'll be talking about, Uranus, Neptune, and Pluto.
Yeah, a lot of stuff.
Yeah, it does sound very familiar. So it's very similar to Jupiter's amount of moons.
Yeah.
So anything else you would like to add about Jupiter or Saturn?
I mean, again, Jupiter is one of my favorites. I love the Mars rovers, though, and I love how they sing happy birthday to themselves. They do have Facebook. There's Facebook accounts that NASA updates with images that the rovers are always taking out there, and just it's fun stuff to get to learn more about Mars. But I love Jupiter too. And, there's so many interesting things to learn about our solar system.
And if you want to learn more about Mars, like I said, there's a great exhibit at the Johnson Space Center in Houston, Texas, but also forgot to mention right up I-35 in Waco, right off Baylor's campus, there's the Discovery Center, and they actually change out all of their exhibits. Sometimes there will be about the solar system, our moon, the planet Mars. You can actually drive different rovers on different planets. So that's something very interesting, and talking a little bit in depth about our solar system, but also about dinosaurs. So you can walk around, get a full tour there. But of course, that's once museums get those hands-on sections really open, and you can learn more about that type of stuff.
Yeah, because some museums are open right now. It's just no hands-on exhibits are currently open.
Right, and I'm sure it varies from museum to museum too.
Right.
So let's look at our schedule for the next couple of days. Like I said, this is part 2 of the solar system. So if you missed part 1, you can always go back into our Facebook and or YouTube page and watch part 1 video. Of course, this is part 2, but we'll be doing part 3 next Monday, and then part 4 the following. So
what are we talking about with part 3?
So we'll be continuing through the solar system.
So the next 3 planets would be Uranus, right?
Neptune and Pluto.
Neptune and Pluto. Nice. And then we're going to be talking about other things out in the solar system too for that next week, correct?
Asteroids, comets, you name it, we'll be talking about.
Pretty
Milky Way. Yep.
And tomorrow, we're continuing Tropical Tuesday. We've talked about so much already with where these hurricanes come from, what tropical systems are named across the world, because they have different names depending on where they are, even though they all are kind of doing the same thing. What they do, the most famous ones to hit, or the most historical ones to ever hit the state of Texas, rather, where you've talked about the hurricane hunters who fly into the storm. We talked about that last week. Fascinating and amazing work that those men and women do. And then tomorrow, we're going to be talking about the structure of a tropical cyclone. So the structure of a hurricane.
So basically splitting a hurricane in half and then talking about what happens inside the hurricane.
Yeah, and then we're going to talk about steering. What steers these storms?
Yeah.
What causes them to move in certain directions? And how do we know what's going on up there to understand where they could be going?
So the tropics, very interesting. Remember, hurricane season starts June 1st.
Yeah, we're
less than a month away. It'll be here before you know it. In fact, there has been some tropical activity already out in the Pacific Ocean. So
yeah, they've already had a system out there in the Pacific.
Yeah, so it's not abnormal. It's you know, tropical systems try to get organized out toward the west in the Pacific. And it's not totally rare, just because we are starting to heat up just a little bit.
Yeah, and it's also not out of the normal for it to possibly happen in the Atlantic early on. I haven't seen any activity out there just yet.
Yeah, so basically looking at the hurricane outlook, I've seen no tropical activity expected over the next 5 days.
Matthew says, how do moons form? And the answer to that is sometimes the gravitational pull for a planet is so strong, if something is passing by, it'll snag it and it will just continue to orbit around that planet. Now, there are some questions as to how our moon formed, whether it could have in the very early stages of our planet, if the moon may have, it could have been 2 planets that kind of collided, and then our moon just kind of stayed nearby. There's a bunch of questions as to how our moon formed. So that's not a guarantee, but they could have collided, and a piece of it just separated from the planet. But there's still a lot of questions in on that.
And remember that Weather Chief Bill Taylor and I did a Moon Monday. And so we talked all about the facts of and interesting information. So that video also lives on our KINS 5 Facebook or YouTube page. So you can find facts about the moon there. And then Wednesday, we'll also be talking about computer models. You know, there are so many weather models out there that tell us the rain chances and the temperature outlooks and show us the weather patterns. So there are multiple updates, not only multiple weather model updates, but also just multiple models in general, right?
Yeah, and then we're talking about all about tornadoes on Thursday, and then Fun Time Friday, where we share your photos and images and stories with you. Matthew said, so planets moon nap them. And Matthew, the answer is yes. So a lot of these gas giants have that strong gravitational pull, and they just snag these large flying objects in space and pull them towards, and then they're just stuck orbiting around the planet.
Well, there you go.
Yeah.
So very interesting stuff with the solar system.
Oh, yeah.
Excited to continue this topic. We really are.
Yeah. And guys, you know, we're going to, of course, have Tropical Tuesday tomorrow. That's at 1 p.m. Be sure to tune in for it, but I'm about to sign off right here.
We are. And stay tuned for any forecast updates that we'll have at 4, 5, 6, and 10.
Yep. Meteorologist Meagan Massey is on KINS 5 at 4. And then Weather Chief Bill Taylor, 5, 6, and 10. We'll see y'all then.
Bye, guys.